Hello everyone, welcome back to our channel, and today we are going to crack a LeetCode problem called squares of a sorted array. This problem will really test your array manipulation ability as well as usage of two-pointer technique to reduce time complexity. So let's delve into the problem statement. So the problem statement says that given an integer array nums sorted in non-decreasing order, return an array of the squares of each number sorted in non-decreasing order. Okay, so you will be provided with an input of a nums which have both negative as well as positive number, and what you have to do is you have to convert this array in such a way that the final output will hold the squares of all the numbers but in a sorted way. Okay, so this is our problem statement. Now let's look at the approach. So one straightforward approach would be to convert each number to its square form, like -4 square is 16, -1 is 1, 0 is 0, 3 is 9, 10 is 100, and then after getting that squared value of the input, we will sort that values, right? So for example, here if you see, if our input is -4, -1, 0, 3 and 10, what we can do is find a square of each number. -4 is 16, and then -1 is 1, square of 0 is 0, square of 3 is 9, and square of 10 is 100. So now after finding the square, it is not sorted, right? Because in our input, -4 is smaller than 3, but after doing the square of -4, 16 is bigger than square of 3, 9, right? So this needs to be sorted. So now when we sort it, this 0 will come here, and then 1 will come here, 9 will come here, 16 will come here, and then finally 100 will come here. Okay, but if we do this approach, if we go ahead with this approach, what is our time complexity? So here first, in our first iteration, like it will just iterate through each number and find a square. So here it will be n, and after we have found our intermediate array, now we will find the we will sort it, right? So sorting would be n log n, right? Time complexity here is n log n. So can we do it in a better way? Like can you improve this time complexity? Okay, so that's where we will use our two-pointer technique. So in two-pointer technique, what we do is we'll have two pointers. First is the low pointer pointing to the initial of the array, and we'll have a high pointer pointing to the end. Okay, and also there is an iterator pointer, okay, or maybe we'll say cursor pointer. Okay, so which will point to the end. Okay, and at the same time, before starting with this technique, we'll have a result array where we will store our all the values. Okay, so we'll have a result array of the same size, and there is a cursor pointer which is pointing to the end of that array. Okay, and so here what we will do is we'll find a square of -4 and we'll find a square of 10. So clearly we can see that 10 square 100 is greater, right? So we'll insert this value 100 here, right? Now what we will do is we'll move our high pointer towards the left, because out of this low and high, the the element pointed by the high resulted in the greater number, right? So we'll move the high towards the left, and we'll store the 10 square value to our current pointer, and then we'll move our current pointer towards the left, saying that uh, if now 100 is sorted, I mean one element has been filled up, so we'll look for the next element. Okay. Now again, in the next iteration, again this low and high will be checked, and we'll see that -4 square is 16 and 3 square is 9. So 16 is greater than 9, right? So this square of this value needs to be inserted here. So that's why what we will first do is, first we'll move the low pointer towards the right, find a square of -4, that is 16, and put it here. And hence move this current pointer towards the left. Okay. Now in third iteration, we will check again the low pointer and the high pointer, and we will see that -1 square is 1, but 3 square is 9. So 9 is bigger, right? So we'll have to move this high pointer towards right, and put this 3 square here, and hence move the current pointer towards the left. Okay. Now we'll see that now we'll again compare our number pointed by left and high. We'll see that -1 square is 1, and 0 square is 0. So 1 is bigger than 0. So this will be put here. -1 square is 1, and hence this current pointer will move towards the left, and this low pointer will move towards the right. Now now we are left with the last element. 0 is here, 0 needs to be here. And then finally this low will move towards the right. Low will move towards the right, resulting in the end of our iteration. So we'll run till here, right? Till the low and height meets. So after they collide, we are done with our resultant array. Okay. So that's how we solve this problem. So let's look at the coding solution now. Let's code this approach. So initially we had 3 pointers saying, let's first define the length of our nums, and then we have 3 pointers saying low, high, and low will point to the first index and high will point to the last index. We also have a current pointer which will point to the last index, and before starting we need a resultant list of n sides. So initially we can simply initialize with 0 and n. Now we'll run the loop. So we'll run till low is less than or equal to high. Okay. So once low goes out of it, I mean it crosses the high, then we'll stop it. Okay. And here what we'll say that we'll check the absolute value of low and high. Okay. And we'll see which is the greater one. So we'll say that if absolute value of nums of low is greater than or equal to. Okay. So greater than or equal to absolute value of nums of high, then we'll put the lower. So we'll say that if that is the case, if the absolute value of low is greater, then result of curve should hold, then result of curve should hold a square of low pointer, right? So here it needs to be nums of low square of nums of low. Okay, and at the same time we will decrement the current pointer and we will increment our low pointer. Okay, else means if low is less and if high is greater, okay, the number pointed by the high pointer is greater, then in that case we will store the nums of high square of the number pointed by high and decrement current and decrement high. Okay, because high is moving rightwards and low is moving high is moving leftwards and low is moving rightwards. Here you can see that current, we anyhow for each iteration we have to put something in the current, so both has the same value. We can take it outside our condition. That's it. So finally we'll return our result. Perfect. We have successfully solved our problem. So this will really help you in array manipulation as well as using a two-pointer technique to reduce time complexity, right? Because right now you have O of n time complexity instead of O of n log n for sorting, correct? So you have done it in one iteration. So this solution is for space optimized as well as time optimized. Okay, so if you found this video really helpful, then please give us a thumbs up and subscribe to our channel. If you have any doubt or suggestion, please put it in the comment box, and please subscribe to our channel to follow more coding problems. And if you are preparing for interview, then it is a one-stop solution. Thank you so much. We'll meet you in the next video. Thanks a lot.